This video is a review of some operations with rational expressions such as these. We're going to go over adding and subtracting rational expressions, simplifying rational expressions, stating the excluded values, and solving rational equations, which is a little bit different. But let's start with problem number one, a subtraction problem. The key to problem number one is remembering to take the greatest common factor of this denominator and factor that out. Do not treat this as one expression. Factor out the GCF of 8. So if you do that, then this is going to become, so I've got p minus 7 over 8 times p plus 3 minus 3 over 8. Now you can see that we have these 8's in common, but this side has a p plus 3 and this side doesn't. So you're going to give this side a p plus 3 factor, and you'll put the same thing in the numerator, p plus 3. Now be careful with the subtraction as well. That's another common mistake. When you do the distributive property later, you're going to want to distribute a negative 3. So I like to change this to a plus sign and put the negative right on that 3. Alright, so when I distribute, okay, so I've got my p minus 7 over 8, p plus 3. Okay, so this is going to give me negative 3p minus 9. Alright, negative 3 times 3 is negative 9. And then I just combine my like terms. So let's see, p minus 3p, so that's going to be negative 2p. And then negative 7 and negative 9 make negative 16. Alright, now oftentimes this is the final answer. But be careful, this time it is not the final answer. Because if we factor out the common factor, it will cancel with the 8. So for full credit, you have to do that. Alright, so when we take out the GCF right now, take the negative with it. So I'm going to factor out a negative 2. Alright, and that's going to leave behind p plus 8. So I had to do that because this 2 and the 8 they will reduce. 2 goes into itself once, 2 goes into 8 4 times. So the final answer is going to be negative p plus 8 over 4 times p plus 3. So if you had stopped here, you would have gotten half credit. Don't forget your excluded value. P cannot equal negative 3, taken from the denominator. Okay, so that's number one, a subtraction problem. So problem number two. Again, we need like denominators, but this time there's nothing to factor, so this is relatively straightforward. The left side is going to need r plus 3. The right side is going to need r minus 4. That makes the denominators the same. So now that the denominators are the same, I can combine these fractions. So I will keep my like denominator of r plus 3, r minus 4. Little distributive property here is going to give me 5r squared plus 15r. Distributive property here gives me 2r minus 8. And that's going to, I'm going to combine my like terms. So let's see, I have 5r squared plus 17r minus 8 over r plus 3r minus 4. And that is the final answer, because this is unfactorable. And excluded values, r cannot equal negative 3, r cannot equal positive 4. So number 3, let's factor. We're just supposed to simplify. In this case, that just means factor and cancel. And of course, as always, we will state the excluded values. I'm not sure why it says like only. Ignore that. So let's simplify and state the excluded values, period. So we need to factor this. All right, these are kind of big numbers, and it's kind of a tough factoring problem. But, you know, oh well, that's life. We got to deal with it. So I don't see a GCF, so let's just go ahead and start trying to factor this thing. So when I look at 4, that's either going to be 2 times 2 or 1 times 4. I'm going to try the 2 times 2 first. So this would be like 2x and 2x. And then I'm looking at the 6. 6 is either going to be 2 times 3 or 1 times 6. I'll try the 2 times 3 first. Well, I can't really do the 2 times 3 because say if I did 2 and 3. That creates a GCF here. That shouldn't happen. And if I switch it around, I'll have a GCF over here. So the 2 and the 3 is not going to work. Actually, neither will the 1 and 6. Because no matter where I put the 6, I'm going to have a GCF between the 2 and the 6. Okay, so that tells me that the 2 times 2 is not working. So it must be 1 times 4. Okay, so it must be x times 4x. All right, so now I'm going to go back to trying my 2 times 3. All right, so say if I do 2 times 3. I know not to put the 2 here. Again, that would make a GCF. Now, inner plus outer must equal the middle. That's the middle. So inner, I have 8x. Outer, I have 3x. That can make 11. It's not going to make 25. So that means the 2 times 3 is not working. So that leaves me with the 1 times 6 option. Now I know not to put the 6 here because that would make a GCF. So I'm going to put the 6 here and the 1 here. Inner plus outer equals middle. Inner, I have 24x. Outer, I've got 1x. I can make a positive 25 if I just leave these both positive. So that means these are both positive. And positive times a positive is a positive 6. So fine, that's how you factor that. I got to do the same thing down here. Got to roll up my sleeves and do this factoring problem. Now 8. All right, let me just clean this up a little bit. All right, 8 is either going to be 2 times 4 or 1 times 8. Say if I started it off with the 2 times 4 like I usually do. Now I have the 6. That's either going to be 2 times 3 or 1 times 6. The 2 times 3 will not work because no matter where I put the 2, that'll be a GCF. The 1 times 6 will not work because no matter where I put the 6, there's going to be a GCF. So that means the 2 times 4 option is not working. So that means it must be the 1 times 8 option. So x times 8x. It must be that. Now, let me try 2 times 3 again. I know not to put the 2 here. That would make a common factor. So 2 times 3. Inner plus outer equals middle. So the middle that I want this time is 47. Inner, I have 16x. Outer, I have 3. That is not going to make 47. All right, so the 2 and 3 didn't work. So now the 1 and 6. I can't put the 6 here. That would make a common factor. So I'll do 6 and 1. Inner, I have 48x. Outer, I have 1x. Together, I can make a 47 if this is positive and this is negative. So positive, negative. Also, a positive times a negative is a negative 6. So that's good. So this is what I have. Now, it's a good time to say my excluded values. X cannot equal negative 6. X cannot equal positive 1/8, setting that equal to 0 and solving. Now, I'm looking to see if anything cancels out. X plus 6 and x plus 6, those will cancel out. So as far as simplifying, my final answer is 4x plus 1 over 8x minus 1. So that's the answer to number 3. All right, number 4. We need to solve this equation. So when I'm solving equations, I'm still going to make like denominators. All right, the difference is I will cancel out the like denominators after I form them. They both have x in common. All I need to do is multiply by 5, numerator and denominator. Now I have like denominators, so I can just cancel those out. All right. By the way, I already see that x cannot equal 0. That's my excluded value. But anyway, so I have 2x plus 4 is equal to 10. Subtract the 4 from both sides, so 2x is equal to 6. Divide by 2, so x is equal to 3. So that's the solution, and it is not extraneous. All right, number 5. Whatever you do, do not just stick a -2 on here, like something like that. All right, I see kids trying to do this, like -2, -2. You can't subtract in order to make them be the same. You can only multiply. So you have to treat these as two separate things. So this is an x, but it needs an x minus 2. All right, this has an x minus 2, but it needs an x. Like, that's what you have to do. Okay, now the denominators are the same, so I can cancel them out. So that's going to give me x squared plus x equals, and I have to double distribute this. So I'm going to get x squared minus 2x minus 3x plus 6. That's x squared minus 5x plus 6. I'm going to get 0 on one side. So I'm going to subtract x squared from both sides, and I'm going to subtract x from both sides. So I'm going to get 0 is equal to, oh, these cancel out completely. So I just have negative 6x plus 6. Running out of space there. Better jump up over here. So in fact, I'll recopy. So I have 0 equals negative 6x plus 6. So now I'm going to, you know what, I think I'll add 6x to both sides. All right, I'm going to move this over there. So I'm going to add 6x to both sides. So that'll give me 6x equals 6. And then I will divide both sides by 6. And I will get x equals 1. Now let's be sure to state the excluded values. X cannot equal, so I want to take a better look at these denominators. Because of the x minus 2, x cannot equal 2. Because of the x x cannot equal 0. So that's it for number 5. All right, number 6. Again, I need to form like denominators. All right, so I'm just going to treat these as two separate factors. So this side needs a 3x. This side needs 2x minus 3. All right, now the denominators are the same. Because it's an equation, I can now cancel these out. I think I'll go ahead and just mention the excluded values. X cannot equal 0 because of setting 3x equal to 0, you get 0. And x cannot equal positive 3 over 2 from setting this equal to 0. 3 over 2. Okay, so I cancel out the denominators. So I'm going to have to double distribute this. Okay, like this. So that's going to give me, hold on. So if I multiply it, 2x times 2x, so that's 4x squared, and then that's plus 6x, and then negative 6x, and then negative 9. All right, so I double distributed that, and multiplying here gives me 3x squared. So these like terms just cancel out. So I have 4x squared minus 9 is equal to 3x squared. Let's get these x squared terms together. So if I subtract 3x squared from both sides, that gives me x squared minus 9 equals 0. So look, right now I have a choice. In fact, let me recopy this. So I have x squared minus 9 equals 0. Here's my choice. I'm going to solve this two ways. One way is to factor this. So this is the difference of 2 squared. So I could go x plus 3, x minus 3. And I can set these each equal to 0. So that'll give me x equals negative 3 and x equals positive 3. All right, neither of these are excluded, so we're good. So that's the answer. Another way I could do it is I could move the 9 to the other side. So now I have x squared equals 9, and then I would take the square root of both sides. Now, if I'm not careful, I'm just going to put x equals 3. And it's like, wait a minute, before I had 2 answers, now I only have 1. That's because I've forgotten that whenever I take the square root of both sides, I'm going to have 2 solutions, plus or minus. So once I put plus or minus 3, then I see that that's the same thing. Okay, so that is how you would do number 6. All right, I'm going to stop this video here because I'm at the end of the page, but I'll do the rest of these problems on the next video.